Okay, guys, so this is Spearman's rank correlation, one of my favorites. A lot of you will use this in your IA. It's kind of like just if you need a little bit more on your IA, you do this one, and it really helps you out. Okay, so the following table represents the data from a random group of teachers and their performance evaluation scores. Is there a trend in the data? Meaning, is there a correlation between the years of teaching and their score? Does this apply if we use Spearman's rank correlation? So let's break this down. You've got this data, teachers with experience, and what their performance scores are, like their evaluations that we get when we teach. Who taught the longest? This 11. Did they have the highest score? Because you would think that the longer you teach, the more experience you get, the better your grade, right? When you get evaluated. And if you look, yep, the highest teacher got the highest grade. What about the lowest one? The lowest one, 3.4? Yeah. Did they get the lowest grade at 65? Oh, they did. Look at that. So, again, you would assume the less experience you have, probably the lower your score. So it looks, just looking at those two, like there might be a strong correlation to the longer you teach, the higher your score. So we're going to do two things. We're going to do Pearson's correlation first. Okay? So let's take a minute and let's just kind of graph this. So I know these are tiny, so this is not going to be super accurate, but we're just gonna try and do it. So I'm going to do I'm just going to kind of put this 1, 2, 3, 4. I'll call that 3, 4, 5, 6. Oh, is that what I want to do? 3. Yeah, 3, 4, 5, 6, 7. 8, 9, and then I've got 11, but I'm not going to have that one. I should have done that better. Okay, so the scores here are 91, so maybe we need to have, like, if we call this 50, 60. I'm not really counting this out, y'all, because the lines are too small for me. 80. It's going to be just a rough graph anyway. Oh, 90, 100. Okay, so 5.6 is 79, so a little bit more than 5 is a 70-something. So we'll put that about right there. 7.2 years is an 85, so that might be like right in here. 7.4 is an 87, so 6 point something is a 69, so maybe they're like right here. 5.8 is a 72. 11 is a 91. So we'll just call that. We'll put that up there somewhere. 6.2 is a 77. And 3.4 is a 65. So my data might look something like that. So if I were to draw a line through it, it would probably look something like that. I don't know. It'd be something like that. Okay, so I'm looking, it's a positive correlation, right? So yeah, it looks good. So what I need to do is go to my calculator, and I'm going to do stat edit. Let me clear all this out from my last one, and I'm going to put that data in. So if you've already done it, you can fast forward the video and go there. Okay, so we're going to do stat, calculate, linear regression. I'm going to go ahead and store it. I know I don't really need to, but it's good to get in that habit. Okay, so here we go. So Pearson's correlation is y equals 3.6. I'm going to do 3 sig figs, so that'll be 2x plus 54.2. The R value is 0.854. Okay. So when I look at this, I would say there is, with 0.854, there is a strong positive correlation. And I'm gonna write this out like I would if I was taking an IB exam and this were my question. This is what I would say. And it appears that the more experience a teacher has, the higher, it's called performance, their performance score will be. Okay, so it looks to me that given this equation and this correlation, it's a strong positive correlation. So the more experience you have, the higher your grade, your performance is going to be. So then we go to Spearman's rank correlation. It's going to work very, very similar to this. So here's what I'm going to do. I want to rank the teachers by years. Who has, oh, I cannot spell, Y-E-A-R-S. Who has the most years? And this is why it's called a rank. So this one right here had the highest rank, right? The next one had, who was next? 7.4? Yeah, so they're second. Then we had 7.2, they would be third. Then we have 6. Oh, we've got 2. Okay, so when you get to a spot, this is person number 4, right? 1, 2, 3. So person number 4, there's 2 of them. So this would be 4 and 5. So what you have to do is go in the middle of 4 and 5. That's 4.5, right? So you label both of these people as person number 4.5. Again, it's 1, 2, 3. They're both person number 4. But there's 2 of them, so it's number 4 and 5. I don't know who's who, so we call it in the middle. So 4 to 5 would be 4.5. So now we have used 1, 2, 3, 4, 5. We're now on number 6, which is going to be this guy right here. And then we're going to have, this will be 7, and this will be 8. Now, we have ranked their experience. We're going to do the same thing, and we're going to rank their scores. I'm just going to call this the score. I'm going to give you a second to do that. Pause your video. All right, here we go. So here's what I got. I got this person was 1, and this person was 2, 87, 91, 87. Then we have 85, so that's 3. Then we have 79, which is number 4. 77 will be 5. 77. 69 will be, who did I miss? Oh, 72, 77, 72. So this one will be 6. This one will be 7. This one will be 8. Yeah, that looks right. All right, so I've ranked them. So we're going to do the same thing that we did with Pearson's. Same thing. All right, stat, edit. All right, here we go. 7, 3, 2, 4.5, 6, 1, 4.5, 8. 4, 3, 2, 7, 6, 1, 5, 8. Okay. Now, if I remember right, I'm going to hope that my video is still going and we're still working. I go to Stat, Calculate, Test, and I'm going to go down and find my Spearman's rank correlation, linear regression double T test. There it is. I'm going to go there, L1, L2. On here, I just go down, regression equation. If I want to do alpha y equals and put it in y1, I can. Make sure I did that right. 814, yep, that was it. I always get it mixed up because it's a little bit different. Now, I want you to look at these numbers because I want to show you something else about Spearman's. So you're like, whoa, what was all that? We did a whole bunch. Don't worry, we're going to go back and do it again. Here's my A, here's my B, just like you're used to seeing it, just on the other one. And if you saw, R was down here, 0.814. It did a regression. That's Spearman's. You can do the linear regression t-test. But I want to show you, look at this, stat, calculate. What if we just did a linear regression? You recognize those numbers? Yeah, we just saw them. So really for Spearman's, you can do the same regression line. The difference is the data we put in is a rank. Okay, we've ranked the data. We can just do a linear regression and still look at it again. So I'm going to set my calculator to the side. I'm going to come over here, and I want to go ahead and let's graph this. Let's just make a graph of it, and then we'll go back and look at all that. So I'm going to do the same thing I did. I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll do 1, 2, 3, 4, 5, 6, 7, 8. All right, so we have over 7 and up 4. And again, it's not looking to be like super accurate. 3, 3, 2, 2, 7, 4 point, or I'm sorry, 4.57, 4.5, 7, over 7, okay, I did that right. I was like, oh, did I mess that up? Over 6, up 6, over 1, up 1, over 4.5, up 5, over 8, up 8. So if I were to draw my line, you can see that's a very strong correlation there. All right, so Spearman's rank correlation. I'm not really looking for an equation on this one. I could write one. What do we get? Y equals, let me go back over here. We got Y equals 0.819x plus 0.813. And we got that R sub S. The S just denotes that you just found Spearman's is 0.81, we'll put 4, which we're going to say is a very strong, rule still follows the same, positive correlation. A correlation is a correlation is a correlation, meaning the R values still maintain the same. If they're a strong R, closer to $1, it's a strong correlation. So let's write that all famous IB answer. The question was, if there's a correlation, does this apply if we use Spearman's rank correlation? Well, we saw that it was a strong correlation, strong positive. So it appears that the more experience and years you have, what can we conclude? The higher your score. So we probably should say yes, we can conclude that the more experience a teacher has, the higher their score will be. All right, and that, my friends, is all there is to Spearman's. I love Spearman. It's a lot of fun to do. Okay, so here we go. So I've got some, let me move that down. Just some more things we're going to do here. So let's talk about the p-value. So you saw on this one when I did stat calculate, actually I did a test. When I did a test for Spearman's, I did that linear regression t-test. And you saw me down here like, what? And I just left it at greater than 0, just meaning my p-value, the p stands for probability. On this, we're going to talk about a p-value, probability that the test of statistics occurred by chance. And this is what we talked about, we're going to talk about level of significance. So when I did this, I just wanted to go here. you saw this little p-value. P is a probability. You want the probability of significance to be super low. That means it's the probability that it didn't happen is low. So anyway, we're going to get into that. So let's just take this problem and kind of look at what's going on and what this p-value means. So a video game or developer is trying to determine if there's a relationship between the rank of a player who purchased more premium items in their game and having a higher playing rank. In other words, if they spend money on the game, is their ranking higher? Maybe they're playing more often. I don't know. To analyze this, the developer took a sample of 10 players who all started playing the game 6 months ago. Determine if there is at least a 5% significance level. This is super normal in statistics. Have something and be given a significance level and try to decide, is this going to work? So I'm going to take this information, and what I want to do is I want to rank the players because he said he wants to know, is their ranking higher? So first off, let's rank by money. Let's call this our L1 and this our L2. Let's rank by money, and then let's rank by their rate. We'll call it rating. Okay, rank by the rating. So I'm going to start off with the money here. This is the highest amount. If you look, it goes down, right? So I'm just going to call this the first. You could go the other direction too. You get the same answer. Okay, 3, 4, 5, 6, 7, 8, 9, and 10. Now, that's how much money they spent. This guy spent a lot. Player A. Now, let's rank according to the rating. So, these are not in order. So, the highest rating was this 98. So, he's going to be our first person. The next highest one is this 95 will be 2. 94 will be 3. Watch out for doubles. 94, so 91. Yep. That'll be 4. 90 will be 5. 85 will be 6. 7. 8. Nope, sorry, this one's 8. 72 is 8. 70 is going to be 9. 68 will be 10. So I got 3, 1, 2, 5, 4, 9, 6, 8, 10, 7. Yeah, that looks good. Okay, so I'm going to go in and I'm going to figure out Spearman's rank correlation. Now, because I'm dealing with probabilities, where I'm trying to find the p-value, to just do a linear regression, if I go to Stat, Edit, and put this in, and here we go, 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Down the other side, 3, 1, 2, 5, 4, 9, 6, 8, 10, and 7. If I just did a linear regression to find that R value, it doesn't tell me anything about the P value. And that's why when you do these, you'll be like, wait, why does this not work? Because I am doing a test of significance. So that means it's still linear. I'm still dealing with Spearman. Spearman's all about being linear. I need to do a double T test. So I'm going to go here. So I'm going to hit enter. I want to know, typically on these, we always do greater than 0. I sometimes do the not equal to 0. I'm trying to think which one I did on this one. I believe I did the not equal to 0. Because I think you actually get the same answer. Let me go back over here. Sorry. It's the joy of watching the videos. When I teach it in the class, I remember which way to do it. But when I'm making the videos, I kind of go, well, which way did I do that? Okay, let me go here. Yeah, you get the same thing either way. So we're just trying to decide, is it greater than a 5% significance? So here's what we're going to do. I'm going to set this over here. I'm just going to cover that up. I'm going to come over here and let's talk about R. Now remember, we're doing Spearman's. So when I do Spearman's, I need to put the little s because this is Spearman's. So let's put that R value. R is approximately 0.0 8.3. I'm going to round it up and put my sig figs. Hopefully you see where I got that. Then the other thing I want to do is that p-value. And when I look at the p-value, I say p, and again, we're going to approximate it. 0.0014, and I'm going to do my 3 sig figs. So this is my first significance figure, then 4, then 7. So here's what I know about this. So now let's talk about this. Remember, we're talking about how much money they spend and what their rank is. I notice here that I have a strong positive correlation, right? Strong positive correlation. What does that tell me? Well, that tells me that the more money you spend on the game, probably the higher your rank. If we're just looking at this, I mean, that's kind of what that's saying. There's a strong positive correlation in the way the data works. So I might want to say in IB language, if I was writing this out, I would say R sub S, or Spearman's rank correlation shows a strong positive correlation. I'm going to say in the ranks. I like that better. Now let's talk about the p-value. We want to know if it's at least a 5% significance level. So we're going to change 5% into a decimal. So it'd be 0.05. We're going to change that into a decimal. P is 0.00147. That is less than 0.05. How we typically would write that, instead of writing this right here, I would just call that P. I've already said what P was. I would say P is less than 0.05. Would you agree with that? Here's what that means. It means that the correlation, since P is very, very small, that means the probability that this doesn't happen is very, very small. Meaning the more money you spend, the higher your rank. The probability is really small. So since it's less than 5%, think of it as a 5% error, if you will. We can, since P is less than 0.05, we can conclude, or we can say, I'll say that, we can say that yes, there is a 5% significance level. That's a good thing. That means it's a strong probability that this is going to happen. You spend money on the game, you're going to improve your ranks. It's not rigged. It actually does happen. Now, let's just put a note up here that we did a linear regression double T test. That was what we did on this. Why did we do the double T test instead of just the linear regression where we can find it? It was because of P. When you have that 5% significance level and you need to know the p-value, you have to do a test. Test for probability. If you're just trying to find a correlation, you can just do a bivariate linear regression. All right, so let's look at the next one. 9 marathon runners are chosen at random to determine whether their position among 100 runners after the first 10% of the race correspond to their positions at the end of the race. Each of the values and find each value and describe the significance of Spearman's rank correlation coefficient. For the data. Determine significance based on a 0.05 level. Now, up here, I think when we did this, we did P does not equal 0, but we checked it and we did greater than 0 work too. I typically say always do P does not equal 0. The probability that it doesn't happen is 0. something's going to happen. It's either going to be significant or it's not. It's not going to be in the middle where it doesn't matter. So you're going to take this. I would pause your video. See if you can do this. Remember, you're going to find Spearman's rank, and you need to find the probability and figure out, is the probability less than 0.05? If it is, then we can conclude that there is a significance. Okay, that it is a significant finding. All right. Hopefully you paused your video, and now you're ready to see if you got it right. So I'm going to go to Stat, Edit. I'm going to put all my data in. You may need to fast forward your video through this if you already did this part. I'm going to plug it in. B2, and then we'll put this one in over here. 9, 7, 30, 22, 50, 46, 49, 93, 70. Oh, you know what I missed on this one? Well, you know what? Since I already put it in, I'm just going to check. I'm just going to do a linear regression because I didn't read very well and I didn't see that it was Spearman's. There is a positive correlation in the linear data, which tells me it's probably going to be a strong correlation when I go to do this one too. Oh, I guess I got to rank it all first. Okay, so if you rank it, this is what I got. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if I rank it over here, I got 2, 1, 4, 3, 7, 5, 6, 9, 8. All right. Here's what I did. Okay, I'm going to go ahead and put it in because I feel like I need to show y'all that. I can't believe I did that. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. On the other side, 2, 1, 4, 3, 7, 5, 6, 9, 8. Stat, I have to find the p-value, so I'm going to go ahead and just do the double t-test. I like to use the not equal, so I'm going to put it there. Here we go. I'm going to set that there. Okay, so, oh yeah, 0.9. And there's nothing else. If I wanted to do suffix, I could put the 0, 0 if I wanted. That tells me it's a very strong positive correlation, which I kind of already knew from the other linear regression I did. Correlation. The p-value. P is, where's P? There's P. Oh, pay attention to that. It is 9.4. I'm going to put 3 times 10. Remember, e to the negative 2 means 10 to the negative 4. Let's write that out. That would be 0. Let's see, I'm going to put 943. And then I have to move it over 1, 2, 3, 4. If it was here, 1, 2, 3, 4. So 0.000, that's pretty small. That's not even a penny. So, can we conclude? What can we conclude? Hopefully, you already looked at this. So I'm going to do the dots for therefore. I'm going to say P is less than 0.05. If you wanted to put 0.000943 is less than 0.05, you could. So I'm going to say we can conclude. That sounds good. Remember, it's all about just writing it out so that you can read it. That there is a level of significance, right, in the rank. There is a level of significance in the ranks. I'm going to go back and read one more time. It kind of throws you off because of this 10% right here, but just know that that's just like labeling what the X is. So there is a level of significance in the ranks at 10% of the race versus how they end the race. So if you take the measurement at 10% of the race done and get the rank here, it almost tells you what they're going to be here. If you're at 10% of the race done, if you're in first place, it's likely that you might get first place. It's not It doesn't guarantee it, but it's pretty likely because look, this person was second and they ended up getting first. So, so we can conclude that there is a level of significance in the ranks at 10% of the race and the end of the race. And the end of the race. And maybe it's almost easier to write it out in words like, we can conclude that where your position at 10% of the race done will be the same as at the end of the race. Has a high probability that it will be the same. Something like that. All right. So let me see what's next. Next we have, I believe it is some check for understandings. Yeah. Okay. We've got I've got 2 check for understandings left, so I'm going to stop the video here and have you do those, and I'll have another video for that.